Welcome to Configuring EtherChannel. Information about EtherChannels, EtherChannel Overview, channel groups and port channel interfaces, port aggregation protocol, link aggregation control protocol, EtherChannel on mode, load balancing and forwarding methods, EtherChannel and device stacks, default EtherChannel configuration, EtherChannel configuration guidelines, auto lag. EtherChannel Overview. EtherChannel provides fault-tolerant high-speed links between switches, routers, and servers. You can use the EtherChannel to increase the bandwidth between the wiring closets and the data center, and you can deploy it anywhere in the network where bottlenecks are likely to occur. EtherChannel provides automatic recovery for the loss of a link by redistributing the load across the remaining links. If a link fails, EtherChannel redirects traffic from the failed link to the remaining links in the channel without intervention. An EtherChannel consists of individual Ethernet links bundled into a single logical link. The EtherChannel provides full duplex bandwidth up to 8 GB per second, gigabit EtherChannel, or 80 GB per second, 10 Gb EtherChannel, between your switch and another switch or host. Each EtherChannel can consist of up to 8 compatibly configured Ethernet ports. Restrictions for EtherChannels. The following are restrictions for EtherChannels. All ports in an EtherChannel must be assigned to the same VLAN or they must be configured as trunk port. Channel groups and port channel interfaces. An EtherChannel comprises a channel group and a port channel interface. The channel group binds physical ports to the port channel interface. Configuration changes applied to the port channel interface apply to all the physical ports bound together in the channel group. The channel group command binds the physical port and the port channel interface together. Each EtherChannel has a port channel logical interface numbered from 1 to 128. This port channel interface number corresponds to the one specified with the channel group interface configuration command. Relationship of physical ports, logical port channels, and channel groups with layer 2 ports. Use the channel group interface configuration command to dynamically create the port channel interface. You also can use the interface port channel number command to manually create the port channel interface, but then you must use the channel group number command to bind the logical interface to a physical port. The channel group number can be the same as the port channel number, or you can use a new number. If you use a new number, the channel group command dynamically creates a new port channel. With layer 3 ports, you should manually create the logical interface by using the interface port channel global configuration command followed by the no switch port interface configuration command. You then manually assign an interface to the EtherChannel by using the channel group interface configuration command. Port Aggregation Protocol. The Port Aggregation Protocol, PAgP, is a Cisco proprietary protocol that can be run only on Cisco devices and on those devices licensed by vendors to support PAgP. PAgP facilitates the automatic creation of EtherChannels by exchanging PAgP packets between Ethernet ports. By using PAgP, the device or device stack learns the identity of partners capable of supporting PAgP and the capabilities of each port. It then dynamically groups similarly configured ports into a single logical link, channel or aggregate port. Similarly configured ports are grouped based on hardware, administrative, and port parameter constraints. For example, PAgP groups the ports with the same speed, duplex mode, native VLAN, VLAN range, and trunking status and type. After grouping the links into an Ether channel, PAgP adds the group to the spanning tree as a single device port. PAgP Modes. PAgP modes specify whether a port can send PAgP packets, which start PAgP negotiations, or only respond to PAgP packets received. EtherChannel PAgP Modes. Auto places a port into a passive negotiating state, in which the port responds to PAgP packets it receives but does not start PAgP packet negotiation. This setting minimizes the transmission of PAgP packets. Desirable places a port into an active negotiating state, in which the port starts negotiations with other ports by sending PAgP packets. Switch ports exchange PAgP packets only with partner ports configured in the auto or desirable modes. Ports configured in the on mode do not exchange PAgP packets. Both the auto and desirable modes enable ports to negotiate with partner ports to form an Ether channel based on criteria such as port speed, and for Ether channels in Layer 2 mode, the trunk state and VLAN numbers. Ports can form an Ether channel when they are in different PAgP modes as long as the modes are compatible. For example, a port in the desirable mode can form an Ether channel with another port that is in the desirable or auto mode. A port in the auto mode can form an Ether channel with another port in the desirable mode. A port in the auto mode cannot form an Ether channel with another port that is also in the auto mode because neither port starts PAgP negotiation. Silent mode. If your switch is connected to a partner that is PAgP capable, you can configure the switch port for non-silent operation by using the non-silent keyword. If you do not specify non-silent with the auto or desirable mode, silent mode is assumed. Use the silent mode when the switch is connected to a device that is not PAgP capable and seldom, if ever, sends packets. An example of a silent partner is a file server or a packet analyzer that is not generating traffic. In this case, running PAgP on a physical port connected to a silent partner prevents that switch port from ever becoming operational. However, the silent setting allows PAgP to operate, to attach the port to a channel group, and to use the port for transmission. PAgP Learn Method and Priority. Network devices are classified as PAgP physical learners or aggregate port learners. A device is a physical learner if it learns addresses by physical ports and directs transmissions based on that knowledge. A device is an aggregate port learner if it learns addresses by aggregate, logical, ports. The learn method must be configured the same at both ends of the link. When a device and its partner are both aggregate port learners, they learn the address on the logical port channel. The device sends packets to the source by using any of the ports in the Ether channel. With aggregate port learning, it is not important on which physical port the packet arrives. PAgP cannot automatically detect when the partner device is a physical learner and when the local device is an aggregate port learner. Therefore, you must manually set the learning method on the local device to learn addresses by physical ports. You also must set the low distribution method to source-based distribution, so that any given source MAC address is always sent on the same physical port. You also can configure a single port within the group for all transmissions and use other ports for hot standby. The unused ports in the group can be swapped into operation in just a few seconds if the selected single port loses hardware signal detection. You can configure which port is always selected for packet transmission by changing its priority with the PAgP Port Priority Interface Configuration command. The higher the priority, the more likely that the port will be selected. Note: the device supports address learning only on aggregate ports even though the physical port keyword is provided in the CLI. The PAgP learn method command and the PAgP port priority command have no effect on the device hardware, but they are required for PAgP interoperability with devices that only support address learning by physical ports, such as the Catalyst 1900 switch. When the link partner of the device is a physical learner, we recommend that you configure the device as a physical port learner by using the PAgP learn method physical port command. Set a load distribution method based on the source MAC address by using the port channel load balance source MAC command. The device then sends packets to the physical learner using the same port in the Ether channel from which it learned the source address. Only use the PAgP learn method command in this situation. Note: the device supports address learning only on aggregate ports even though the physical port keyword is provided in the CLI. The PAgP learn method command and the PAgP port priority command have no effect on the device hardware, but they are required for PAgP interoperability with devices that only support address learning by physical ports, such as the Catalyst 1900 switch. When the link partner of the device is a physical learner, we recommend that you configure the device as a physical port learner by using the PAgP learn method physical port command. Set a load distribution method based on the source MAC address by using the port channel load balance source MAC command. The device then sends packets to the physical learner using the same port in the Ether channel from which it learned the source address. Only use the PAgP learn method command in this situation.